Hello everyone, I hope you all are fine and preparing well for your examination. This is my new video related to Maxima and Minima. This is also the part of application of derivatives. Continuously I am discussing with you the different topics related to application of derivatives. These topics are very important for you for the competitive examination as well as for your board examination. And for your board point of view, Maxima and Minima is clearly a very important topic. Okay, so in this video I am going to discuss the concept of maxima and minima, and in the next video I'll discuss the derivative test and the examples related to maxima and minima. So let's start. So what is the meaning of maxima and minima and how to analyze the concept? So for that I have considered a graph here, that is y equals to fx. This graph is defined in an open interval AB. Okay, so how will you define maxima? Okay, so here you can see that I have marked a point, that is C, and if you are going to plot the value of on the y-axis, then it will be FC obviously. So C then FC. If we consider any other value, like suppose x1 here, okay, if we consider this x1, then what will happen? If you are going to draw, you will get here fx1. Okay, and clearly you can see that fx1 is less than fc. Okay, it means fc is the higher value than fx1. So if you consider another value, that is x2, then in that case what will happen? If you draw this, then you will get this. So this is fx2. If you consider this, then again you can see that fx2 is less than fc. So what I want to tell you, that if we consider in this interval any value, okay, any x that is belonging to open interval AB. Okay, so for that what is happening, that your fc is always greater than all fx. So if this happens, it means your fc is the maximum value in this interval. Then your C point is called point of maxima, and fc is called the maximum value of the function in this interval. So this is the concept of maxima. So first of all, what we are doing, we have taken a function that is defined in an open interval AB, and now what we are saying, that the highest value, how are we going to see that highest value? That in that interval, if we choose any other point, then all points, means suppose we have taken any x in that interval, then fx is always smaller than fc. So if this happens, then your C is point of maxima and fc is the maximum value of the function in that interval. So this is what the concept of maxima. Is it clear? Now you see the next, that is minima. So what is the case of minima? If we talk about minima, that is also the similar. If we consider the graph can look like this also. So now we have considered the graph in this way. So if this is the graph, okay, y equals to fx, it is again defined in an open interval AB, and we have considered this point C, so obviously this value is fc. So if we consider any other value like x1 here, then this point will be fx1. Okay, so here you can see that fx1 is greater than fc. Okay, is greater than fc. So it means that in this interval, if we choose any x belonging to AB, then your fc is always smaller than all the fx for x belonging to this open interval AB. Then your C is called the point of minima, and fc is the minimum value of the function in this interval. So this is called minima, and that is maxima. Is it clear? So now you can see the case of local maxima and local minima. So what is the meaning of that? Just see, if we consider such kind of graph, then what will happen? You can see here, this is the point of maxima, this is also the point of maxima, this is minima, and this is minima. Okay, so it means a graph can have more than one minima and maxima also. Okay, so first of all, you just keep this in your mind that a graph can have more than one maxima and minima also. So what is the meaning of local maxima and local minima? If we talk about local maxima and local minima, then what is the meaning of that? Suppose if we consider this graph, okay, so you can see in this graph what is happening, that we have taken h. Okay, h is our positive quantity and it is very small, but it is positive quantity. Okay, and c1 is our extreme value. Extreme value means the function attains the maximum value in for that. Okay, so c1 is that point at which the function attains the maximum value. So we have taken a very small interval c1 minus h to c1 plus h. Okay, then in this interval, if we choose any x in this interval like c1 minus h and this is c1 plus h, if we take any value x belonging to this interval, then for that your fx is always smaller than fc. Okay, in this interval your fc is the highest value. So for this particular interval, c1 minus h to c1 plus h, fc1 is called fc1 here. So fc1 is called the local maxima. Local maxima because we have chosen an interval. Okay, we are talking about a particular interval around c1. Okay, so that is called the local maxima. If we talk about the local minima, same theory here. We have taken same theory. You can see here that we have chosen b1 minus h and b1 plus h. So in this particular interval, if we take any x, then what will happen? That your fx will always be greater than fb1. Means fb1 is the smallest value in this interval for the function. Then it is called the local minima. This point is called local minima point and this value is the local minimum value. Okay, so like that, here can be many local maxima and local minima. So what about the highest value? See, these we got like that, we got many values. Okay, like here also, here also, here also, here also. So if we collect all the local maximas, then the highest value among all will be called the absolute maxima. Similarly, if we collect all the local minimas and we consider the minimum value among all, then it is called the absolute minima. Okay, absolute minima. So if we consider here, just take an example. If the graph looks like this goes like this goes like this goes like this. Okay, then suppose like this. Okay, then we have considered here this is, here this. So if we consider them, then obviously this is the local maxima, this is also the local maxima. But if we are going to consider both of them, this value will be little higher. So this will become your absolute maxima. Here it is also the local maxima, but as it was the highest value, so we are going to consider it as the absolute maxima also. Likewise, we can consider absolute minima in the minimum case. Okay, so this is what the concept of local maxima, local minima and absolute maxima and absolute minima. Here the definition is written: the maximum value of the function in its domain, that is called the absolute maxima, and the minimum value of the function in its domain is called the absolute minima. So this is just the concept of all the four words. In the next video, I'll discuss the first derivative test. Because why we are discussing about that? Because in the graph it's very easy to see the maxima and minima. Anybody can answer after having the concept. Okay, but if the function is written in this form, fx equals to, suppose the function is written x square plus 1. If it is given in this way and they have asked you to find out the local maxima and local minima value, okay, in the particular domain, then how will you calculate? So for that we need the derivative test. So in the next video I'll discuss the derivative test with you and the other concept related to maxima and minima. It's a very wide topic, so obviously we need many videos to clear your concept. So first of all, you go through this video and clear at least the meaning of this word, these words, local maxima, local minima, and absolute maxima and absolute minima. Okay, so thank you so much, and all of you stay safe.